Welcome. We are continuing, trying to make things easier in the physical sciences, suitable for grade 12 learners and teachers. This is one part which is very enjoyable, that is chemical equilibrium, full of stoichiometric calculations, and also there will be the application of Chatellier's principle, calculation of Kc, and its interpretation. We are taking a question, a recent question that was written now. The question is question number 6. It says a certain amount of sulfur and 0.3 mole of oxygen gas are sealed in a container at 340 degrees Celsius. The reaction reaches equilibrium according to the following balance equation. Now they are telling us, first one, 6.1. I say define the term chemical equilibrium. Remember, we've got two definitions of chemical equilibrium. It depends. First, all be in terms of rates. You will now say is when the rate of the forward direction, or when the forward direction rate, forward reaction, is equal to the reverse reaction. That's the first option. The second option can be in terms of concentration, to say when concentrations of the reactants and products remains the same, remains unchanged, remain constant. So whatever weight that you might use, 6.2. How will each of the following changes affect the yield of sulfur dioxide? According to this balance equation, we see that solid sulfur is reacting with 1 mole of oxygen gas, forming in a reversible reaction with sulfur dioxide. Now write down increase, decrease, or remains the same. 6.2.1, when more sulfur is added. We know solids has no effect on equilibrium, therefore this one is an obvious one, that it will remain the same. 6.2.2. now is a question of pressure. They say pressure is increased by decreasing the volume of the container at constant temperature. When we look at this reaction, we see that 1 mole of gas is on the left, the reactant side, and 1 mole of the gas is also on the right hand side. Therefore, pressure won't have any effect on this equilibrium. Again, it remains the same because equal moles of the gas appears on both sides. 6.3, they are now saying it is found that the equilibrium constant Kc increases, underline that Kc increases when the temperature is increased. Also underline that one. Kc increase, temperature increase. Is the forward direction exothermic or exothermic or endothermic? Fully explain the answer. Now we start with the first point of Kc increase. Increase in Kc value favors the forward reaction. It's a matter of principle here. Forward reaction, and that more Kc increases means that more content of the products is increasing, while that of the reactants decreases. And then we know again increase in temperature. Increase in temperature favors the principle as well, an endothermic reaction. Now we can infer or just make a conclusion here between the two statements. So increase in Kc favors the forward, increase in temperature favors endothermic. Therefore, it means that the forward reaction is endothermic. Forward reaction is endothermic. We are concluding now. Endothermic. Done. We get the 3 marks. 1 mark, 1 mark, 1 mark. So 6.4. 6.4, they say to us, how will the addition of catalyst influence the equilibrium constant of this reaction? Remember, catalyst has no effect on equilibrium because it decreases both the forward reaction rate and the reverse reaction rate equally. Therefore, also we know that only the change in temperature affects the Kc value. Therefore, this one remains the same. Remains the same. The reason being only Kc value is affected by the change in temperature. Next one, it's a long 6.5.1. 6.5.1. This one now we're going to calculate. Now in the 6.5.1, they're saying to us the graph below and not drawn to scale shows how the amount of sulfur solid in the container changes with the time. Therefore, equilibrium is reached at 340 degrees. Calculate the equilibrium constant at this temperature. The volume of the container is 500 cubic centimeter. We convert it immediately to say the volume of the container has to be now 0.5 dm cube because we are not going to use cubic centimeter. Now we are supposed to calculate, because we are given 2 masses here, the initial mass and the final mass of in this case sulfur. Now we have to calculate the number of moles. Number of moles of sulfur initially, then will be given mass over the molar mass, which is the same as 10.7. The mass of sulfur is 32. Therefore, we find 0.334 mole as the initial mass. The final mass of sulfur when we reach equilibrium, then it will be the same in this case. And then now we are having 8.1 divided by 32. Then you get with your calculator 0.253 mole. Fine. Now we know the initial moles. We can go to the table now. Let's copy the equation as it is. Sulfur plus oxygen, reversible sulfur dioxide. Very easy. What do? We draw 5 lines below this equation. 5 lines. 1, 2, 3, 4, 5. 5 lines. Each substance must have its own column. In this case, a column for oxygen, column for sulfur, and then this side we leave this mole space just to show the examiner that I'm working with moles. This will be the initial moles, change mole, moles at equilibrium, and concentration at equilibrium. Now the initial mole of sulfur is 0.334, and that of oxygen was given in this initial statement. If you look at this one, it's 0.3 mole. Then it will be 0.3. Nothing is set up by the product. We are starting from 0. At equilibrium is found that number of moles of sulfur is 0.253. This will give us more information to fill up the whole table. Now we get the difference. Therefore, it's give us that we have used 0.081. That is the number of mole decomposed for sulfur. Now using the mole ratio, mean that the whole lot will be 0.081, positive 0.081. Now we go to the equilibrium. This will be the same, 0.081, and then this one will be 0.219. We divide everything here by half, which will be the same as multiplying by 2. Then we know that the solid has no concentration. Cancel this, and then the oxygen will have 0.438. That is this one divided by 2, and this one divided by 2 also will be 0.162. Now we have got the concentrations at equilibrium. We can calculate the Kc. We write the Kc expression. Remember, no solids in the Kc. We'll just replace the concentration by 1. So we'll have sulfur dioxide divided by concentration of oxygen. This is our Kc expression. We can substitute. Substituting here in the Kc will be 0.162 divided by 0.438. Therefore, the answer, if you use a calculator, it will be 0.37. If we align with approximating to the minimum second decimal, or we can write 0.36986. That's the 9 marks. Remember, the table is having 4 marks. According to this one, let's just discuss the allocation. So just to enlighten many of us here about the allocation of marks here. 1 mark will be for the change here. If you know from the table the initial and final, then you'll get 1 mark. 1 mark will be for the ratio, usage of the ratio, then which is 1:1:1. And then 1 mark will be also the change in the reactants here. That is here 219 will get 1 mark. Again, if this one equals to this, we'll also get 1 mark for the 2. And then if you have divided everything here by the volume, that's the 5th mark. So you get 5 marks in the table because of this change. Fine. And then this from here, the 1 mark will be for the Kc expression, and then the 2nd mark will be the substitution, and the last mark will be this one. So all in all, it should be 9 marks. Where is the last? There will be now the number of moles, the usage of 32 in the calculation of initial moles. The usage of 32 will give us the 9th mark. So it's 9 out of 9 in this case. Thank you. And then let's go to the last question in this. They say, once you have determined the Kc, can you in 6.5.2 now determine the Kc value for the reverse reaction? This is very simple. Kc value for the reverse reaction is the reciprocal of the given Kc, and that Kc for the reverse will be 1 over Kc for the forward. If this is the reverse, it will be 1 over Kc for the forward, which is the same as 1 over 0.37, and then this will give us the answer, which is 2.704. That is the answer for 2 marks. We're getting 2 marks here. That is the, or maybe 1 mark for here, 1 mark here. So fine, just for distribution. So that was 19 marks, the whole question, which is one of the best question in the paper 2. That's Kc calculation. We'll deal with also questions where now case is given and then you are given the time to deal with this. So otherwise, thanks a lot. Till next time, bye.